This is Entangled Interviews, the interview program by REPISC, the Ibero-American Network for the Advancement of Quantum Software Engineering. Today, we are joined by Marcos Lordello Chaim, professor and researcher at the University of São Paulo in Brazil. Marcos earned his bachelor, master's, and doctoral degrees in electrical engineering from the State University of Campinas. His research focuses on software testing, debugging, maintenance, with a particular interest in program analysis tools and their practical evaluation. Since 2022, he has also been exploring how quantum computing systems can be analyzed, tested, and debugged. I'm Alejandro Fernández, and I'll be the host of this episode.
Hi, Marcos. How are you? Welcome to Entangled Interviews.
Thank you so much, Alejandro, for the invitation. My name is Marcos Lordello Chaim in Portuguese, but it's okay. I'm an associate professor at University of São Paulo. I work in the School of Arts, Science, and Humanities of the University of São Paulo. It is the newest school of the University of São Paulo. It started in 2005, so it's only 21 years old. So I'm a professor of the Information Systems course and of the program on graduate program on information systems. We have a research group called the Software Analysis and Experimentation Group, where we basically our record is in software testing and debugging, especially debugging. I have worked quite a lot in debugging.
Mm-hmm. In classical, all of that before you went into quantum, right?
Yes, before I ended up working with quantum software engineering. Before joining the University of São Paulo, I worked in a state-owned research company in Brazil called the Embrapa, which is agricultural research agency of Brazil, where I was a C programmer there. I developed software there. I was a software developer, so I have some background in the industry before joining the university, and I've been working with software testing, classical software testing, especially data flow testing. Alejandro, there are two types of researchers. There are those that are that have large vision and try to start a new area, and there are what they call the frogs. Those that take one subject and study a lot one subject. And I was obsessed with data flow testing. I couldn't bear that it didn't scale up. So I worked 10 years in trying to enhance this data flow testing. So I have, I would say, quite interesting papers in data flow testing and how to use it in debugging.
And how did you move from testing and data flow to quantum computing?
Okay. I published a paper on ICST, International Conference on Software Testing, which is quite reputable conference. And I was invited to chair a session. It was 2021. I was invited to chair a session, and there was this Shawkat paper called the Quito, where he proposed a kind of functional testing for quantum computer. And there was a Bell circuit there. I couldn't understand anything about that, but I thought, here there is some interesting things here. Something that they are stochastic, there are indeterminations, and I had 10 more years before retiring. So I thought, I'm gonna try something wild. I mean, okay.
It happens. It happens.
I say, okay. So to be honest, I said, okay, let's try something different. I mean, I decided to study quantum computing.
Yeah.
That was 2021. I have no students. I have students that work with software tests and debugging. And then I found a student that was interested in a PhD program.
Yeah.
So I said to him, okay, we have this. I can advise you in software testing, debugging. You're gonna work a lot to try to publish it. It's very competitive, and it's tough.
Yeah, yeah.
And there are this new area that I want to try. I think that there are a lot of possibilities, but it's a risky business.
Yeah.
I don't know how this is going to turn out, but and then he joined.
But always from the perspective of testing.
Yes.
So using everything you're strong on, all your strength on testing, to do this new developing domain.
Yes, but when I first read this Q2 paper from Shawkat,
yeah,
I noticed that it's very different from regular classical testing.
Yeah.
We cannot use what we know about oracles. We cannot use what you know about coverage. We cannot use what we can, for example, for debugging, breakpoints.
Right.
We cannot use. Then I said, okay, I told this to my student. They also, I said, look, we have possibilities here, okay? But I cannot assure you where this is going to end. But it's up to you. Yeah. And he said, I mean, let's go for the second option. And then we start studying. We studied the main papers. Then I had a previous student, PhD student, that he was just joined the university. He's now in the Polytechnic School of University of São Paulo, but he was in another university. And he said, okay, Marcos, there is this workshop from FSC. They are trying to new things for the 2030 software engineering new stuff. Do you have something? I said, okay, I'm studying. We are studying testing in quantum software engineering, and he joined the group too. Igor is another. He's also a colleague that works with us. And then we started studying, and I said, okay, let's see what are the relevant problems in this area. Well, what is the challenges? Okay, so then we end up with a paper on testing.
Did the first student graduate already? Did he already get the PhD, or is he still on it? The first student you mentioned.
He's my first student. He just qualified.
Excellent.
He just qualified, but he has to finish up his program.
Okay, but the bet paid off. I mean, he will have. Yeah.
Yes, it's interesting because it's something that I joked with them. I say, okay, if everything turns out wrong in this, I go home. I'm finished. The problems are yours. Okay. But I'm 60, Alejandro, so
Yeah.
I have a few more years around. So I
Yeah.
said to them, okay, I said, okay, guys, I'm fine if something is not gonna
Yeah.
end up well.
But
It's something.
I think the topic is quite safe. The fact that testing poses a different kind of challenges in quantum computing is clear. Uh, what will happen with quantum computing in general is still an open question, but testing is clearly a challenging problem. So in that sense, it's safe. Now, going to the topic of testing and being that a classical software engineering topic, testing is something that software engineering has been discussing for years. I know you were at ICSI in Rio de Janeiro a couple of months ago. Great conference. Shame that I couldn't go there. A couple of colleagues of mine went there. They said it was amazing. Everything was about artificial intelligence. Um, but you were there hosting the Quantum Software Engineering Workshop, QSE. Um, uh, Tell me a bit about it, and tell me also a bit about the reaction of the classical software engineering community to having people talking about quantum computing there.
Okay, it's interesting because when I was invited to chair this conference, this was my first international conference that I would chair. I thought I was a little bit afraid. I mean, because it's something completely different for me. But it's interesting because the scope of the papers are very large. I mean, we had papers about, let's say, untraces and machine learning, how to use, how to develop, how to choose untraces and ansatz, I guess.
Yeah.
In machine learning, we had papers about skills required for testing. Okay. So, but we also have papers, for example, that deal with how to select services, how to select the best performance for the price. We had papers, the difficulties from migration. For example, there was a very interesting paper that said, okay, we had QoAO running in Qiskit 1.x, and it doesn't run anymore. So it was.
How do we migrate that? Yeah.
This is one of the difficulties of our area. I mean, a change of version of a framework stops something that was working well, and then you see it's a hidden perimeter. It's a hidden. I'm not. I can't recall exactly what, but it was.
I remember. I read the article because we're doing something similar, and it tells a bit about the level of abstraction we have in quantum computing now. That very small details break things. That's because one of the things that we need to do as software engineering experts for quantum computing is raise or create new abstractions. Work at different abstraction level. And
in this conference, what was very interesting, I think, because the scope, for example, we had, for example, a paper discussing how to model simulation in quantum. So it's proposing MDE, model-driven engineering for quantum simulation. And to be honest, in test, we had a paper about the skills and a paper that is about debugging. But the others are regards another issues in software engineering. So I think that our community is still in baby steps to find what is more relevant. Testing is definitely one thing very relevant because, I think as a classical software testing researcher, I want to, let's say, cover things.
Yeah.
I want to okay, see what is see if the test passed or failed. Flaky tests is the very nature of quantum testing.
Yeah.
Basically, all tests are flaky.
Yeah. And you don't know what the flakiness comes from.
Yes, you don't know. Though I think it's our research are very focused on testing currently in quantum software engineering.
Yeah.
I think there is a lot to do.
Yeah.
Because this Alejandro, for example, one thing that I'm interested in research-wise. Okay, what is a failure in quantum testing? What is a failure in NISQ area? And when you try to simply run programs, when you go from 5 qubits to 10 qubits, everything go wild. I mean, in terms of NISQ area. Okay.
Yeah.
I see. So one thing that I quite interested is say, okay, can we extrapolate from testing a qubit count of 5 for let's say 100 qubits?
Yeah.
Probably not. But definitely, I think that we need to think a lot how to understand the small scale, if you can imply things from small scale to large scale, because it's something that I don't know if it's possible, but it's something that it's in background in my mind. And,
I understand what you're saying. What you're saying is we're trying to describe what testing is, have a theory of testing quantum systems, but we are working with examples that don't really represent what quantum programs will be when these machines will be running. I mean, we're trying to test 100 qubits, tens of qubits, but the future of quantum computing is thousands, tens of thousands. So how do we make sure that everything that we try to create now scales? Wow.
Yeah, it's something that
I mean that shouldn't stop us. That shouldn't stop us because even if we're generating knowledge for the pilot scale that we have now, all of that maybe it doesn't scale like that, but all of that knowledge will be somehow will feed the future steps. Interesting.
One thing that it's not clear for me yet, because we have a very sound theory of, let's say, when you take Aman and Ofut book, it's a classical testing book. You say, okay, there are this model that say, okay, we have a bug. This bug is, let's say, a code error, and then there is an infection. This infection propagates, and then it reviews. We don't have this model, I guess, for quantum. We say, okay, one thing that we noticed in our testing survey is that we don't have bugs. We don't have bugs. We don't have mutant operators that are based in real bugs. They are basically guesses. Okay, let's take off a gate. Okay, it sounds okay for me.
So mutation is basically, let's try to change the circuit without any real logics. Is that what you mean?
Yes. I mean, they are not, because when you take the theory from mutation theory, it's okay.
Yeah.
Okay, it's basically programmers' mistakes that are modeled by mutant operators. Okay, but they come from a knowledge
real bugs. From real mistakes.
Real mistakes. And at least we say, okay, let's take let's add a measurement here. Okay, it's okay. It sounds plausible for me, but we don't have yet, in my opinion, a sound theory of what is a common bug in quantum. And I can also say, because we did that in a paper that we published this year, that the bug, the bugs database that we have comes from frameworks and not from applications.
Yeah, because they're not.
We don't know what are the applications bugs. We have bugs from frameworks development, but from applications. In this paper, we use the Python notebooks as a proxy for applications, but it's still a proxy. It's not. We don't have yet a large database of quantum or hybrid quantum classical applications to let's say mine and find the bugs.
That takes me to the title of the talk you proposed for. I mean, I have to say, advertise that you will be visiting our city, La Plata, in August for a research stay with us, supported by the RIPASC network. But you will also give a talk at the Argentinian Symposium on Quantum Computing. And the title you propose is From Pattern Mining to Concept Composition in Quantum Software. It seems that this idea of mining what's done by developers, it's something that you do a lot. Like you need to mine real mistakes to do testing. So tell me a bit about what will be new about this talk that you're planning to give. What is mining? What do you plan to do with mining patterns and go from there to composition?
Okay, Alejandro, this is not new for you, but when we start researching, we start with an idea, then more interesting things appears on the other side. We start searching for testing patterns in quantum software. We were interested in testing, right?
Yeah.
And then we start to study quantum patterns. And there is a site, I don't know, it seems that it's offline right now, but it was called the Quantum Patterns Catalog, I guess. It has some kind of, Gang of Four style, you know.
Nice.
You have intent, everything that that framework
Nice.
from the and this site tried to catalog all the patterns that was developed, and then we try to mine this software. We try to first of all identify in the frameworks if we find these patterns.
Yeah.
Then we mine the frameworks. Then we also mine the
tests.
We mine the patterns in Python notebooks.
Okay.
Also, we thought, okay, Python notebooks are our proxy for applications. In doing that, we noticed, first of all, from around 60 patterns in the catalog, we found only, I guess, 22 or I don't remember exactly the number, but it's about one third in the frameworks. What it means that we have a catalog that doesn't appear in practice. I mean, okay.
Yeah, that wouldn't have passed the Hillside group testing for patterns. That would. I mean, when the patterns community at least require that you have known uses for the pattern. So this is mostly like proto patterns, what would be called. Yeah, but
let's say maybe it can appear in another repositories that.
Yeah. Okay. That we did. Yeah. Yeah. Okay. You didn't find the evidence. Let's say that. Yeah.
But in this, we didn't find, right?
Yeah.
And also we found new patterns that didn't appear. So we also found around 9 patterns that appeared in the papers, in the frameworks, but were not cataloged. And then from this idea, we start to say, okay, I called my students, say, what about try to see how to connect these concepts, these patterns, as a way to build new quantum systems.
Yeah.
So the idea right now, what we plan to present in ASQC.
It's getting complicated with that many letters that we are inventing as computer scientists.
And we plan to show, let's say, how we, from this initial idea of mining patterns, testing patterns, we end up studying patterns in general. And then how to connect these concepts of quantum concepts as a way to develop a system. Right?
Yeah,
this is the idea.
Yeah, I mean the patterns and the whole idea of Alexander, the timeless way of building this idea of patterns as generators of systems and architectures. Was very useful. I mean, it was a game changer for classical software engineering. It gave us a higher level language to describe our systems. So what you're doing is, it's basically, this already worked for us, trying to identify patterns and see how they connect and build languages and build maps. Let's reuse that method that we know it works, and it helps us find abstractions. So looking forward to that talk. Let's stop there. If people is interested in your talk, they have to come to La Plata. I invite the drinks afterwards. No, I don't invite. It would be my intention to invite, but let's erase that part of the interview. If people want to hear you, they have to come here. So let's move forward because we have 44 minutes. I would stay for hours talking to you, but that's going to happen in La Plata. There are 2 more parts of this interview that have to do with the classical idea of entanglement. that I don't know how entanglement is it emaranhadas? ¿Cómo se
Emaranhado.
Emaranhadas. Entrevistas emaranhadas. Yeah. Okay. Okay.
That's correct.
Yeah, we have to apologize to the Brazilian. I have to apologize to the Brazilian people because I don't speak Portuguese. I should speak Portuguese, but I'm embarrassed that it would be like Portuñol, not even good Portuñol. So, but we should do the effort to speak each other's languages.
Alejandro, it's completely off topic.
Yeah, it's off topic, but it's important.
I have a difficulty to speak Spanish.
Yeah.
But I can explain offline. But it's I particularly have some difficulties in Spanish in particular. But it has to do with the structure of the language.
Yeah.
But it's no excuse. But just to.
But we should do. I mean, an apologize is in place because this is the Regi Latinoamericana, pero ¿cómo se dice? How do you say advancement?
Rede
Latinoamericana.
Rede Latino-Americana para o Desenvolvimento
da Engenharia do Software Quântico.
Engenharia de Software Quântico.
Yeah. I said it once when I record the Spotify introduction for the podcast, and I forgot it. Okay, but the apologies are in place. I hope that before the project ends and before I retire, I can speak Portuguese. Now, let's go to the Amaranhadas part of the interview. Our last interviewer, that was Laura Gatti from University of Montevideo, left a question for the next guest, that is in this case you. And this is the question that Laura left, is which area of quantum computing do you think would be the best to develop in Latin America? So, for example, should we focus on hardware, software, cryptography, communications, sensing? What do you think should be our focus?
First of all, I'd like to say that it's a great idea about these entangled interviews. I mean, it's fantastic. I love it. Okay. I was thinking about this question, and a few years ago, I wouldn't say what I would say right now, but definitely I think today it's hardware.
Yes,
it's hardware. I mean, I know that's difficult. I know that we don't have the budget to address this. But you know, Alejandro, we are living in a world where it's not a soft world. It's the power is not soft anymore. It's hard power. So it's very easy for our region to be in a situation where we will be denied access to some kind of hardware. I don't know what is the best technology. I don't think that we have resource to investigate all the technologies. But definitely, I think that we have to have a coordinate effort to develop some kind of hardware development, quantum services available in our region, because we are not living in a time where we are good, everything we are protecting, we are in the same hemisphere. We are not in this world anymore. So I think that software eventually is going to be worked out. I mean, in some way we are going to. I think that I would definitely try to set up a coordinate effort to develop some effort on developing hardware and a service associated to the hardware.
Yeah. I see what you mean, because if we look what happens with artificial intelligence, even though artificial intelligence is software, those that have control are those that have the hardware. And it's a general hardware, but it's a matter of budget, whether you can have that or not. We should learn from that and don't simply give up sovereignty, control. Yeah. Don't simply give it control, saying, okay, you build the hardware, I'll do software, because that's a strong dependency. Is that what your point is?
Yes.
Yeah.
You know, this is a political issue here currently in Brazil. I'm not political. I mean, I'm just a regular guy that is worried about the availability of development, resource for development to our countries. I mean, let's say you took the example of AI. For example, there was a denial of access to a particular model under, let's say, security reasons. But you can raise any reason if you want to achieve some goal. I mean,
in quantum computing is not far from using the same argument.
Yes.
Quantum computing and security are very strongly related, at least in the discourse. So,
if I could also say a second option would be cryptography.
Okay.
In the same argument. I mean.
Yeah. Excellent. And now moving forward, now you had to entangle the next interview. So I ask you for a question for the next interviewer. I don't know who could be, but just give a question. Shoot a question.
This is another question that is in my background. I mean, for me, because I teach in an information system course. I mean, I'm always thinking about what should I teach my students to develop quantum systems. My question for the next interviewee, I guess.
Yeah, I think it's in Spanish. I think it would. Go ahead.
Entrevistado.
Yeah. Okay. Guest. The next guest.
The next guest is. Should we? One question is okay. What should we teach to our students to develop quantum system? And more, will our students develop quantum algorithm circuits? Should we worry about teaching how to create algorithms based on circuits? This is one thing that is in, or should we teach them how to connect modules? It's something that it's it's something that I have a possible answer, but I will leave for the next guest. But it's something that really is in my mind as a software engineering researcher and teacher.
It's not a simple question, because when you take it only from our perspective, is what should we teach the students that come to our computer science engineering courses? That's one way of thinking about the question. But that leaves out that the systems, the quantum computing hybrid systems, will also be developed by people from other disciplines. Maybe we also have to think, what should physicists or mathematicians teach their students so they can contribute to the hybrid quantum classical systems, because it's not going to be a one discipline problem. It's not just a thing about computer scientists anymore. So it's a complex question. Nice. I will try to write it down so I don't forget it. And it will be for the next guest. We have to find who. Okay, with that, we can wrap it up. Thanks a lot for your time. We'll see in 2 weeks in La Plata to have a drink, a beer, a coffee, Coca-Cola, whatever. And
okay. And I saw that you are a mate drinker.
Yeah, of course.
I will bring you a nice coffee for you.
Yeah.
In La Plata.
Yeah, because you don't drink Chimal.
São Paulo is coffee country.
Yeah, it's coffee country. Yeah, and also chocolate. And also, you also have good chocolate.
Santa Catarina, it's mate country.
Yeah. Okay. Brazilian coffee, it's the favorite here, at least in my family, so it will be welcome.
Okay.
Okay. See you.
Nice to.
Obrigado.
Alejandro. Bye-bye.
Bye.